All right, I'm continuing on with the implicit differentiation practice problems in the book. And so I got up to 7 on the last one, even though I think I might have to redo number 7. I think I forgot something, but we're going to start out with number 9 and I'll go back and do 7 later on. So I have x squared y squared equals x sine y, x squared y squared plus x sine y equals 4. So the first thing I want you to recognize is I've got the product rule going on here. So I have f equals x squared, f prime equals 2x dx, g equals y squared, g prime is 2y dy. And I have the product rule going on here because it's x sine y. So I'm going to run out of room here a little bit, but I'm going to do f is x, f prime is 1 dx. We just put dx. G is sine y. G prime is cosine y dy. So I've kind of got both of those set up. So we're going to have to do the product rule twice over here. So I'm going to skip a little space here just so we have room to do all of this. Okay, so the first one we're going to do f prime g. So I have 2xy squared dx. So f prime g plus fg prime. So plus 2x squared. No, this is xy squared, and this is 2x squared y dy. Sorry about that. I said that wrong. So I did 2x y squared dx. Fg prime is 2x squared y dy, right? So I did the first one. Plus, now we're going to do f prime g sine of y dx plus fg prime plus x cosine y dy. And the derivative of 4 is 0. So that's a little bit of a mercy here. So now we're going to solve for dy dx after we divide through by dx. So I've got all terms here, so I'm going to divide through by dx. And when I do, thanks for playing. So I'm going to leave the 2 dy dx's on this side, and I'm actually going to factor it out at the same time. So I have a 2x squared y left from this term, and then I have a plus x cosine y. Then the other two terms, I'm going to move over to the other side. So it's going to be minus 2xy squared and a minus sine y. Okay, so I move those on the other side. And then I'm going to divide by this. So I have 2y dy dx is going to be negative 2xy squared minus the sine of y all over 2x squared y plus x cosine y. I guess that wasn't as bad, just with trig derivatives in there. So that's number 7. Okay. No, number 9. Sorry, that was number 9. All right, the next one we're going to do is 11. Okay, so this one has trig in it as well. So I have 4 cosine x sine y equals 1. Well, there's a couple ways to do this. You could, but when I do this for the product rule, I'm going to call this my f and this my g. You could do it without the 4 in there, but I don't know. I just think it's a little cleaner and neater. So I have f is 4 cosine of x. F prime is going to be minus 4 sine x dx. G is sine y. G prime is cosine y dy. All right, so let's go through and do the derivative. So I have f prime g, and when I do that, you'll notice f prime g for this one right here is you're going to have 2 signs going on here, but that's okay. So I have negative 4 sine x sine y dx. All right, and then it's plus fg prime, so 4 cosine x cosine y dy, and the derivative of 1 is 0. So that makes it nice. And I'm going to go through and divide through by dx because I have 2 terms here. And I see, thanks for playing, that one's going to go away. So I'm going to leave the dy dx over on this side. So I have 4 cosine x cosine y dy over dx. That's going to equal a positive, yep, a positive 4 sine x sine y. And then because I'm solving for dy dx, I'm going to divide by all this. So I have dy over dx equals 4 sine x sine y all over 4 cosine x cosine y. So I like this one because it makes you, because trig always adds another level. The first thing you notice is I can divide that out to make a 1. So I could write it as this, sine x sine y all over cosine x and cosine y. But then I looked in the back of the book and that's not what it said. So that's kind of cool to look at it. And if I look at it like this and like this, I recognize, oh, sine of x over cosine x is tan of x times tan of y. So I find that interesting that you can do that type of thing, is to go through and do the derivative and then find out, oh, there's an easier way to write it. And there you go. So that's 11. That was fun. 13. So 13 I want to do with you because it's got a little bit going on here, but it's kind of fun as you get to do this. The first thing I want you to notice is I have e raised to the u, and my u, or my exponent, is a quotient. So let's kind of set up our f and g's over here. So f is x, f prime is dx. You should be used to this. G is y, g prime is dy. And when you go to do the derivative, this is the cool thing. So you're going to rewrite it, because the derivative of over e to the u is always e to the u. There you go. Then you're going to leave the exponent alone, and then you're going to multiply, here's your chain rule, by the derivative of the up here, and I know it's a quotient. So you can do f prime g, so I got y dx minus x dy. So f prime g minus f g prime, and I don't know what I just hit. Go away. All over g squared, so I have y squared. Okay, so that's cool. Equals, now you're going to take the derivative of the right, which is going to be 1 dx minus 1 dy. So we can write it just like that. And then everybody looks at this and said, oh my goodness, I have a quotient there. So let's do something really smart and multiply both sides by y squared to get rid of the fraction. And when I do that, remember you have to do it to both, okay? So this makes it a little bit easier to continue forward. I have e to the x over y, okay? The y squareds will cancel out. And you can, we'll go slow, y dx minus x dy. And this will be y squared dx minus y squared dy. So the right-hand side is kind of ready to divide through by dx, but the left side is still not. You always want to have terms, so we're going to distribute this. So I'm going to have y e to the x over y dx minus x e to the x over y dy equals y squared dx minus oh, yeah, y squared dy. I caught myself there. So now we got everything going on here. Okay, so now we're going to go through and divide through by dx. Thanks for playing. There's a dy dx. This is a dx. Thanks for playing. There's another dy dx. So again, it doesn't matter which side you're going to go. I think I'm going to go to the left just because I'm used to doing that. So I have dy over dx. Okay, what do I have left is a negative. Well, let's bring this one over first. So it would be a positive y squared minus x e to the x over y. So I just took care of, I just kind of put this one in front because I knew I had to move it over. And then this right here equals, and then I have y squared minus y e to the x over y. All right. Now when I do that, I just have to go through and divide by everything in the parentheses there. So I have let's get this ready, dy over dx equals y squared minus y e to the x over y divided by y squared minus x e to the x over y And the only thing different, I mean, that's perfectly fine with me. The only thing the book did differently was they actually factored out a Y on the top, but I kind of don't do that unless I can simplify the entire thing. So that would be perfectly fine. So I just finished number 13. So we're getting there. We're getting there. So that's the end of this video, and I'll make another one for the rest.